The directions say to factor and then solve. If we take a look at this first problem here, we first need to factor out the greatest common monomial factor, and then we need to set it equal to 0 and solve it. So in 18c squared plus 6c, the greatest common monomial factor would be 6c. When I take 18c squared and divide that by 6c, I'm left with 3c plus the next term, 6 divided by 6 is 1, c divided by c is 1, so we're only left with 1, and this equals 0. So we've done the first step of factoring. The next step is to solve it. Set each of these terms equal to 0, 6c equals 0, and 3c plus 1 equals 0. In the first problem here, c would have to equal 0 in order for the problem to equal 0. In this problem here, we subtract 1 from each side. 3c equals negative 1. Divide both sides by 3, and c equals negative 1/3. The solution to this equation is 0 and negative 1/3. If we look at the example on the right over here, problem number 2, it's similar, but there's an extra step at the beginning. We need to bring this negative 30p from the right side over to the left side. I'm going to do that by adding 30p. So I have negative 12p squared plus 30p. And if I add 30p to both sides, the only thing left on the right side now is 0. I'm going to factor out the greatest common monomial factor. And whenever the leading coefficient is negative, we want to make sure that you factor out a negative also. So the greatest common monomial factor would be negative 6p. If I divide that out, I'm left with 2p minus 5. And that equals 0. Remember, one way to check to see if you factored correctly is to distribute that monomial factor to both terms to see if you get the answer that you started with. All right, so now we've factored. Now we need to set each of those equal to 0. Negative 6p equals 0, and 2p minus 5 equals 0. Negative 6p equals 0. P has to equal 0. In the second part on the right, we start by adding 5 to each side. 2p equals 5. Divide by 2. And p equals 5/2. So our solutions are 0 and 5/2.